Today, we're looking at a new breed of AI. And this isn't your typical generalist model. Nope, this is a specialist, an AI that's been specifically forged to think, create, and debug code like an absolute expert. Its name is NousCoder 14b.
You know, this whole thing really puts a fundamental idea to the test. It's all about seeing if an AI can actually start to think like a competitive programmer, to really get that deep logic, the nuance, and the sheer efficiency that defines the best human coders. So let's dive in and see what it can do.
So what is NousCoder 14b exactly? Well, it is definitely not a jack of all trades. It's a specialist, through and through. It was honed using something called reinforcement learning, which is a pretty cool process. It's basically like teaching the AI by rewarding it for finding the most elegant and efficient solutions to really tough programming problems. It learns by succeeding, over and over again.
To forge an expert like this, you have to realize it's not just about dumping more data into the system. Not at all. It's about a super targeted, really intense training regimen that's designed to build a very, very specific skill set.
And the foundation here is absolutely key. NousCoder 14b started its life as Qwen 3.14b, which is already a seriously powerful base model. But you got to see that as just the launchpad, right? That was just the starting point for its transformation into a coding specialist. And get this, the training process was unbelievably efficient. We're talking just 4 days. In 4 days, running on a cluster of 48 high-end GPUs, the model chewed through over 24,000 different coding problems. This wasn't some long, slow marathon. It was an intense, all-out sprint to build that expert muscle. And the result of that sprint? Well, it's pretty clear. On the live code bench, which is a really tough benchmark that uses recent programming challenges, the original base model passed about 61% of the time. Not bad, but after that specialized training, NousCoder 14b's success rate shot up to almost 68%. A jump of over 7% might not sound like much, but in this world, that is a massive leap in capability. Okay, so benchmarks are one thing. They're important, for sure. But the real test is seeing how it handles practical, creative tasks. Let's see how it does when we ask it to build something from the ground up, just from an idea.
The first challenge was straight out of the real world. The prompt was to take a list of modern design requirements, a compelling hero section, a sign-up form, nice feature highlights, a cool gradient design, and of course, it had to be totally mobile responsive, and turn all of that into a complete landing page for a new product.
And the result? It was flawless, absolutely perfect on the very first try. The model just generated a complete, professional-looking web page. It was fully responsive, and it hit every single requirement from the prompt. No need for revisions, no tweaks, just a finished, working product. Incredible! Now, generating code is impressive, no doubt, but finding those hidden critical errors in existing code, that takes a whole other level of understanding. This right here is the ultimate test of an AI's coding logic. So, the challenge was escalated big time. NousCoder 14b was handed a complex C++ program and was tasked with hunting down some of the most difficult, most dangerous bugs a programmer could ever face. And we are talking about some really nasty stuff here. These are the kinds of bugs that give developers nightmares. Memory management errors like use after free and double free, which can cause all sorts of unpredictable crashes and major security holes. It was even tested on a race condition, a super complex timing bug that is notoriously difficult for even the most experienced human developers to track down. While the results just speak for themselves, NousCoder 14b found every single one. It correctly identified each one of those critical bugs, showing this profound understanding of code execution, of memory, of concurrency. This wasn't just good debugging, this was expert-level debugging. So when you look at the benchmarks, the creative code generation, and that incredible bug-hunting performance, it all points to one powerful conclusion about where coding AI is headed. The core insight we can pull from all this is that highly targeted reinforcement learning is an amazingly effective way to seriously level up an AI's programming skills. And, maybe just as importantly, it can be done in a surprisingly short amount of time. And that brings us to the main takeaway. The path to creating these expert-level AIs isn't just about making them bigger and bigger. It's about specialization. That kind of focused training is what turns a capable AI into a truly indispensable expert tool. This kind of performance leaves us with a really compelling final thought. Forging an expert programmer in just 4 days demonstrates that the next great frontier is applying this same specialized approach to other complex fields. You start to think about things like drug discovery or material science, and the potential just seems immense.